Hello everyone, welcome to MindMatrix. So here we are with another lecture on operating system. So this is the second lecture that we are going to cover today. So let's start. Before starting, let me introduce myself, those who are new to our channel. So for them, I'm introducing again. So my name is Anshul Sharma and I'm upcoming software engineer to at Juniper Networks. Currently, I'm pursuing M.Tech Computer Science from IIT Kanpur. I have a teaching experience for more than 2 years, mentored more than 1,000 students as of now, and I have the expertise in computer science and data science subjects. If we talk about the achievements, I have secured All India Rank 294 in GATE Computer Science, cleared ISRO NIC NELET exam, also got selected as Administrative Officer at AIC. So you can join our doubt discussion telegram group, so you can just scan this QR code and you will be able to join our telegram group where you can ask your doubts. Also, we will be sharing all our lecture PDFs in that group so that you can refer it and you can make proper notes. Okay, so let's start with our next topic, that is process management. So in process management, first of all, we will be talking about what is process, right? What is PCB? And we will also be talking about the fork system call. How can we create a process? So all these topics we will be discussing in this lecture. So let's start with what is process actually. We know as a programmer, as a user, when we write some lines of code, we call that as a program, right? We call that as a program. It can be in C language, or it can be in C++ or any other programming language. So we call it a program, the lines of code. But when we load that program into the main memory and when we run it, when we execute it, it becomes process. Okay, so we can say a process is nothing but a program in execution. So it is an active entity. Simply, a program is a passive entity, and when we talk about process, it is an active entity. So some authors, if you read the standard textbooks, some call, some say that when you load the program in the main memory, it becomes process. And some authors say that when you load the program into the main memory and then you run it at least once, then it becomes a process. So it is a kind of a gray area. Uh, the answer can be yes, answer can be no, but a simple definition can be a program in execution is called a process. Okay. So this is the memory layout of a process. So we have the text section, or we can say the code section is there. We have the data section where we have the static variables, we have the global variables. So in the data section, we have the heap for dynamic memory allocation and stack for, activation functions and all. Heap grows upwards and stack grows downwards. So this is a kind of memory layout of a process. Okay. Now let's proceed further. So there are some attributes which are associated with the process, with every process. So if you talk about a single process, we have the identifier, which is the unique ID for a process. We have the state, we have priority of a process, program counter, right? Where the next instruction to be executed, the value is stored there in the program counter. We have memory printers, we have context data, input output status information, accounting information, and much more. So these are the attributes that are there in a that are associated with the process, and all these details of the attributes we store somewhere, and I will let you know what it is. So basically it is a program control, a process control block, so we store all these information there. But before that, we need to understand one concept here, which is context switching. So if we talk about context switching, so here, what do we mean by context switching? Basically, let's say we have a program, or let's say we have a process P1. Now let's talk about in terms of process. So we have process P1 and we have one process P2. Let's say we are executing one process P1 and we preempt that process. So basically, preemption means we are taking the control or the CPU, back from the P1, and we are giving it to P2 so that P2 can execute. Okay, so that is preemption. Okay, so now, before, you know So this is known as context switching. So before even executing P2 or giving the CPU to P2 process, there is some uh, there is some concept called as context switching, where we save the context of one process and we load the context of another process to be executed. Okay, so that is called as context switching. When we say saving the context of one process, what do we mean? So basically we are storing all these information of the process, okay, before before executing another process. So that is saving the context of the process. Context switching can happen when a high priority process comes to the ready state, an interrupt occurs, user and kernel mode switch, preemptive CPU scheduling used. So all these things we will be discussing later on in the upcoming lectures, but you should know it as of now that what is context switching and what we do in context switching. Clear? Let's proceed, and now we talk about the process table. So we have the process table. So it is a data structure maintained by the operating system to facilitate context switching and scheduling. It contains all the current processes information, or we can say the process control blocks in the system. Okay. So here we can see this structure. So this is your process table where we have all the current processes which are present in the main memory. Okay, and we have the process control block for each process. So one single process control block will be storing all these information, will be storing all these information. And if you see, for single process we have PCB1 associated with the second process, we have its own process control block. Okay, so what is actually process control block? So process control block is nothing but a data structure of struct type. So we can write here, let's say this is PCB, and here we are having all the information stored. So this is the data structure that is storing the information or the attributes of a single process. So this is for P1. Similarly, we are going to have it for P2 and all the processes which are there in the main memory. I hope it is clear to you. Okay, so and this we can have a hash table of all the PCBs, or we can maintain a linked list also. Okay, so which is, first we are going to have a PCB for process 1 and then for process 2 and so on. Okay, so this is what we have as process control block. Now so this is the concept that we discussed in the previous lecture also, how a program is run on a machine. So we as a user writes a program, compiler converts the program into executable code, or we can say the byte code. User requests operating system to run the byte code. Operating system loads the program into the memory. So basically using loader, it loads the program into the main memory, and then it sets the registers properly and start running the code. This is what happens. Now we need to understand here, or you may have a doubt also, that operating system is also a code, right? Right, operating system, we have operating system, so that is also a code. Now we are executing, we are talking about executing the process, loading into the main memory, executing it. We are talking about that, but operating system, what about it? This is also a code, right? So operating system, that is already there as the executable code. We have the executable code, or the, we can say, the compiled code in our secondary memory. So we have the executable code of the operating system in our secondary memory or hard disk, you can say. And when we switch on the computer, so basically the bootloader program, it is going to, which is there in the ROM, this is there in read only memory. So this bootloader program knows the address of the operating system or the executable file of operating system which is there in the secondary memory. It knows the address of that. And when we switch on the computer, so it knows the address, it is going to load this executable code, or we can say it simply the operating system, from the secondary memory to the main memory, and then it is going to run it. So then operating system, once the operating system is loaded into the main memory and it starts executing, then it is going to take care of each and everything, whatever programs we are going, whatever processes we are going to run, and everything that is there as a service provided by the operating system. So that will be taken care of by operating system. So this is what is I don't know what happens when we switch on the computer. Is it clear? Now, now we need to know, let's come back to our topic, that is process. So we can say informally, process is nothing but programming execution. Process contest for resources, or we can say compete for the resources. We have if we have multiple processes and some resources, so more than one process may require a single resource. So processes competes for the resources, and we will be talking about that in the upcoming lectures. And context of a process, we have already talked it about, right? That is the context switching. And what is context of a process? All the attributes, all the details of the process that is stored in the process control block. And the fourth one is multiple processes at the same time. So we can have multiple processes in the main memory, and we are going to execute it one by one, right? So this is what we have for the process. Now, now let's talk about creating a new process. So let's say if I want to create a new process, so we can use fork system call. This is very very important, and in the gate exam also they have asked questions based on that in the previous years, and they may ask again also. So this is very important. Carefully understand this concept, creating a new process. So we use fork system call, right? Now we need to understand here that we have two system calls here, or we can say simply fork exe. So this fork, what it does, it is going to create space. It is going to create space for your executable file. Okay, so let's say you have one program that is, let's say, demo.c. You compiled it, and finally you are getting the executable code, which is demo.out. So when you call fork, it is going to create the space in the main memory for demo.out. So this is the first step. What about exe? It is going to load. First space will be created in the main memory, right? And then it is going to load this demo.out in that space. Okay, so this demo.out will be loaded in that space, and then it is going to execute further. So now first let's talk about what is fork if I want to create a new process. So what it does, it creates an exact replica of the calling process. So to understand it properly, let's say I have one program like this, int main, and here I have, let's say I'm calling fork, and here we have a printf statement. Let's say I'm calling I want to print hello. Fine, return 0. Now here you can clearly see that we are calling fork here. Clear? When I execute this statement fork, what will happen? It will create a similar copy. It will create a similar, or the exact copy, I would say, not similar, exact copy of the parent process. So let's say this is the parent process now, and let's say this is the child process. So exact copy will be created. Okay, now here let's say you call this fork statement, this entire copy will get created, and after that, both the parent process and the child process will start executing after the fork statement. That means from here on. So this parent process is also going to print hello, right? And similarly, this child process is also going to print hello. And it can be in any order based on the scheduling, whether you are first executing child process or parent process. So it can be printed in any order. Okay, but both the processes, when you called fork, then after that both parent process will execute the following statements and the child process will execute the following statement. That means after this, not child process is not going to call it fork again. It is going to execute the statements below it. Clear? So two times hello will get printed. I hope it is clear. We are going to take many examples, so don't worry. It will be much more clear after understanding those examples and after seeing those examples. Let's say this first one. So now we have this program here, int main pid is equal to fork. So now we need to understand one more thing, one more concept here. Whenever I'm calling fork system call, what it does. So basically it is going to return some integer value, some integer to both parent process and child process. This is the first thing. And also it is going to create exact copy of the parent process or the calling process, you can say. Clear? So first of all, it is going to create the exact copy of the parent process. It is going to return some integer value to both parent and child process. And what value does it return? So basically for parent, for it is going to return 0 for child process or to the child process as PID. Okay, and it is going to return some non-zero value, or we can say the ID, process ID of child to the parent, process. So this is what it is done by the fork system call. So to the child process, the value as 0 will be stored in the PID, and to the parent process ID of the child, that is the non zero value, will be stored in the PID of parent process. So let's see how it is going to execute. So we have int main, then int PID is equal to fork, right? Now for child, so basically as soon as you call fork, again the same exact copy will get created. For child, it is going to have, so let me write here, PID will be equal to 0 for child process. So now if you see here, if PID is equal to 0, that means this statement will be true for child. Why? Because the value of PID is equal to 0 for child process. So this printf statement will be executed by the child process, and here it is saying I am child. Okay. If PID is not equal to 0, in that case this else statement will be executed, and this will be executed by the parent process. Because as we know, the fork system call will return the process ID of the child, or we can say the non-zero value, to the parent process. So in that case, parent will be executing this statement, that I am parent. It is going to print it, I am parent. So in this way it is going to execute it. Clear? Now let's see here. So similarly, we can see the example here also. So if PID is equal to fork, again it is going to create the exact copy of the parent process. PID is equal to 0, child will be printing I am child, else statement will be printed by the parent, I am parent, and process ID of the child will also be printed. Okay, so whatever value that is returned by the fork system call will be printed by this statement. Okay, it is going to be it is going to be some hexadecimal value. Okay, so that you can try executing it. Clear? Now now I have shown you with with the example also. As soon as you call fork system call, exact copy is created, right? And after that, after this fork statement, everything will be executed by both child and parent process. So let's say this is your parent process, exact copy is created, we are calling it as child process. So here if PID is equal to 0, so this will be executed by the child process. So here this is the child process, it is going to print I am child, and else statement here will be printed by the parent. Here else statement will not be printed by child because PID is not equal to 0, PID is equal to 0 here in case of child. So this, so here I'm just showing you how the exact copy is created. Ultimately the output is going to be child will be printing I am child, and the parent process will be printing I am parent and the process ID of the child. Clear? So this is just for your visualization that exact copy is created, exact lines of code is there in child process as well. Clear? But you have to just see that okay, only this statement will be executed by the child, this statement will be, these statements will be executed by the parent process. I hope it is clear to all of you. Now let's see this another example we have. So int main printf gate 2024. So we need to see here how many times this gate 2024 will get printed, how many times gate DA will be printed, how many times gate CS will be printed, and how many times MindMatrix is going to get printed, okay, in the output. So let's see here. Int main, the execution will start printf. So as of now only one process is there, that is the parent process. So I can say here clearly that gate 2024 will be printed once. Clear? And then we are calling the fork system call. So after calling the fork system call, now child process will be created. If PID is equal to 0, so this statement will be true for child process. So that is going to print gate DA. So we can say gate DA will be printed once by the child process. Correct? Else statement will be true for the parent process because PID value of parent is non-zero. So it is going to print gate CS once. This is also this is going to be printed by the parent process. Clear? Then what about this MindMatrix? This is outside else. So this printf MindMatrix. So this MindMatrix will be printed by both child and the parent process. So we can say twice. Both child and parent process will be printing it. Is it clear? Correct? Now let's proceed. Now we can understand in terms of logical memory as well. So this is the memory layout of a process, right? We have the code segment, the data segment, we have the heap and stack, right? Now when I call the fork system call, identical memory layout will be created, exact copy will be created for the child process as well. Correct? So this is what we have as logical memory. This is the logical memory of the process. Clear? Exact same logical memory will be created for the child process. Clear? So for the child process as well, exact copy will be created. So both the addresses, now this is very important point, the addresses will be same, the logical address will be same for both parent and child process. This is very important because they have already asked question in the gate exam and we are going to solve that question as well. So understand this point that when we call fork system call, the same memory layout with same logical address will be there for child as well, right? But if we talk about storing that in the main memory. So main memory, we have physical address. Physical address will be different. Physical address will be different. Let me explain you here. So we have, let's say we have this main memory. We have the main memory. Let's say this is our program. Let's say P1 process is there and we call fork system call. So P1 will be there in the main memory and P2 will be there, or we can say the child process will be there as well in the main memory. This is having different physical address. This is having different physical address. So physical address of both parent and child are different when if when we talk about storing in the main memory. But if we talk about the printf statement, so printf will always, we can write here, printf always print logical address, not the physical address. And logical address for both, let me write here for your notes, logical address for both parent and child are same. Logical address will be same, okay, but the physical address will be different. That means when we talk about physical address, that means where we have that parent and child process in the main memory. Okay, clear? Now let's say this program, so let's say this is a parent process. Now if fork is called, let's say this is a process P1. If fork is called, same child process, exact copy of the child process will be created, right? Now if fork is equal to 0, now for child, so we can clearly say that child will be executing this code and else part will be executed by the parent process, correct? Because fork is going to return 0 for child and non-zero value for the parent. So let's say a value is equal to 10. So in that case, child will be getting a is equal to 10 plus 5, that is 15. So here in the main memory for child, a value is 15. Okay. Now printf will be printing the value of a. So it is going to print 15 here. And what about this one, the address of a? So as I told you, printf always print the logical address. So it is going to print some, let's say for example, some hexadecimal value. Let's say it is just for simplicity, let's consider it as 100. Let's consider this as 100. Okay, so it is going to be some hexadecimal value because it is the address, or you can say the ID. So let's say it is going to print 100. Okay, now this parent is going to execute these lines of code. So parent also going to take a value as 10, so and a is equal to a minus 5, so a will be 5 for parent. So here the value of a will be 5, okay, in the main memory, in the main memory. So here if we print this, 5 will be printed. What about this one? So as I told you again, printf always print the logical address, not the physical address. So this is also going to be 100. So both the addresses are going to be same, exactly same, because printf always prints the logical address, and logical address for both parent and child are same. Clear? So let's see here another example, kind of similar example. A value is 50. We are calling fork system call. Child process will be executing this. Parent process will be executing this one. Right. So here the value of child will be printed. That is going to be 55 because a is equal to a plus 5. Here the address will be printed. Let's say it is 500. So here the value will be printed by the parent, that is a minus 5. So it is going to 50 minus 5, that is 45. And again the same logical address will be printed, that is 500. Just we are considering example, but logical address is going to be same always. Clear? Now let's see this question that is from previous year GATE CSE 2005. So here carefully say this. Consider the following code fragment. If fork is equal to 0, a is equal to a plus 5. So there is a printf statement which is printing the value of a and the logical address. So printf logical address, clear? It is going to print. Else part will be printed by the parent process a minus 5 a and ampersand a. Clear? Now carefully understand, read this question. Let uv be the values printed by the parent process and xy be the values printed by the child process. Clear? So we can say parent process uv value. So this is parent, this is this will be executed by the parent. So we can say this is u and this is v, and here this is x and this is y. Now which one of the following is true? Very simple question. So after understanding the concept clearly, you can easily solve this question, right? So we know this, that the value here, we can say x will be equal to, let me change the color here. Yeah. So x will be equal to what? This will be executed by the child process, right? So x a will be equal to a plus 5. So we can say x is equal to a plus 5, correct? Now what about this u value? U will be equal to a minus 5, correct? And what about v and y? So we know this, printf always prints the logical address, and logical address for both parent and child process is going to be same. So we can easily say that v will be equal to y. This is for sure. Clear? V will be equal to y because the logical address is same. What about this one? So here we can solve this. We can substitute also. So from this equation we can get that a is equal to u plus 5, and if we substitute this in this one, so x will be equal to, in place of a we can write u plus 5 plus 5, x will be equal to, so that is going to be u plus 10. So x is equal to u plus 10 and v is equal to y. So if you see the options, so u plus 10, yes, option C is the correct answer. X is equal to u plus 10 and v is equal to y. This is the correct answer for this question. Simple, right? Let's proceed further. Now we are going to solve questions for based on fork system call. So if you solve these questions, you will be able to solve any question based on this. So let's proceed here. This is the first question. Now what will be the output of the following program? So we have this program here, int main printf hello, then we are calling fork system call here, then printf world and return 0. So this is very simple. First of all, hello will be printed because there is only one process as of now. Now you called fork system call. Now there are two processes. So we can say two processes. So world will be printed by two processes, parent process and the child process. So world will be printed 2 times and hello will be printed 1 time. We can also solve this question using process graph. So we have this main, carefully see this, we have this main, we are having this printf statement here, this one, the first printf statement here. After that we have this fork system call here. So as soon as you call the fork system call, child process will be created, and now both child process and parent process will be executing from the statement after the fork. Now world, printf world will be printed by both child and the parent, this statement, and then they are going to return 0. So here you can see this printf will be printing hello, this will be printing world, and here also this will be printing world. So this we call as process graph. We can use this process graph to solve these type of questions, okay? And if it is simple, then you can directly also solve it. Now how many times hello will be printed? Now what about this one? So here you have int main, then you have 2 times fork system call, then printf hello, and then exit 0. So let's make the process graph. So we have main here. Then we are calling fork system call. So child process will be executing now and parent also. Again, you are calling fork system call. So the parent's child will be created, and the previous child's child also get created, right? Now, then we are calling printf. So this is going to call printf, this is going to call printf. So we have four processes in the system. So all four processes will be printing hello, right? All four processes will be printing hello. So four times hello will be printed. I hope it is clear. You can use this process graph, or you can solve this question like this also. Let's say you have a single process first. You call the fork system call. So you have the parent process, its child will get created. Let's say it is C1. Again, you call fork system call. Now you have two processes in the system, P and C1. So you have P, and again its child will get created. Let's say it is C2. Similarly for C1 also, child will get created. So here we have C1 and its child is, let's say, C3. Now you have four processes in the system, 1, 2, 3, and 4. Now you have printf hello. So this also going to print hello, this also going to print hello. All the four processes will be printing hello. So you can use this method or you can use this method to solve these type of questions. Okay, so four times hello will be printed. Now what about this question? Okay, this is the previous question. So the approach I have given you here, that you can use as process graph, already explained it to you. So now you can refer it and you will be getting more clarity. Clear? What about this one? How many times hello is going to print? Now, here we have int main, int I, for loop is there, I is equal to 0, I less than 2. That means this loop is going to execute how many times? When I is equal to 0, when I is equal to 1. That means 2 times it is going to execute. Clear? You have fork system call and you have printf hello inside this loop only. Clear? Then return 0 outside, and then you need to find how many times hello is going to print. So it is very simple. Now carefully see this. Let's use a process graph. So you have main, then this loop is going to execute, fork system call is executing, so its child will get created. Carefully observe here, right? Then you are printing hello. Okay, so printf statement is there, printf statement is here. Then again this loop is going to execute because this loop is executing 2 times. So again fork system call will be executed. So after that the child's child will also be created, and this original parent child also be created. Clear? And then again printf statements are there. So all four processes will be printing, and then it is going to exit the loop and then return 0. So how many times hello is going to print? So 1 time, 2 time, 3, 4, 5, and 6. So answer is going to be 6. 6 times hello is going to print. I hope it is clear to all of you. Again, I'm telling you, you can use this tree based approach as well. So let's say you have process P. Now first time the for loop is executing, fork system call. So here you have parent process, its child is going to create C1, printf hello. So hello is going to print by both the processes. Again this loop is going to execute for the second time, fork system call is executing. So here you have P, its child C2 will be created, and similarly for C1 also, its child C3 will be created. Now again printf statement, so hello will be printed by all four processes and then return 0. How many times? 1, 2, 3, 4, 5, 6. 6 times hello is going to print. Clear? Now let's say this one now. How many times hello is going to print for this code? Now here if you see carefully, we have the for loop here, and inside for loop we have the fork system call, but printf statement is outside the for loop. Clear? Again this loop is going to execute 2 times, when I is equal to 0, when I is equal to 1. So how many times hello will be printed? It is very simple. You have process P, For the first time for system call will be executed, its child will get created C1. Then again for system call will be executed. So here you have P, here it is C2, here it is C1, C3 will be the child of C1. Right, now you have four processes and all four processes will be executing the printf statement because for loop is, for loop executed two times. So here it is hello, 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 and hello. So four times hello will be printed. So answer will be B, that is 4. Now let's see this question. Write down all the possible patterns printed by the following code. So here you have int main, if fork is equal to 0, printf A, else printf B, and then there is a wait system call here. Okay, like fork is a system call, wait is also a system call, right? It is going to wait until the child process completes its execution. Okay, now now carefully see what are the possible patterns we can have. So for child, this if statement will be executed, it is going to be true, right? So printf A, so we can have A, let's say if child is first executing, so we can have A. Then we can have, there is two possibilities, either this parent process is going to execute B, so we can have B here, right? Now this is going to wait, so for child C will be printed, and then after child is executed, then parent process is also going to execute this printf statement C. So this is first possibility. What is the second possibility? The other possibility we can have is, let's say first, parent process is scheduled first. So in that case, first B will be executed. Now parent process is going to wait until the child completely executes. Then there is a possibility that this child process is going to execute. So we can have A, and then child will be printing C, and then parent will be printing C. What other possibility we can have? There is one more possibility. If child is executing first, we can have A here, right? There is a possibility that child will be executing its printf statement first, C also, and then parent is scheduled, so parent will be printing B, and then at the end parent will be printing C. So these are the three patterns that are possible here. Okay, I hope it is clear to you. Let's proceed to the next question. How many child process will be created? So this is the code we have. I is equal to 1, I less than equal to 3. Now carefully see, this for loop is going to execute how many times? 1, 2, 3. 3 times it is going to execute. And we have one for statement in this for loop. Clear? So how many child process will get created? Carefully see this using the tree based approach. So we have this process P. For the first time, child will be created C1. Then again for the second time for system is called. So here we have C2. For C1 also its child will be created, let's say C3. Then again for the third time for system call is executed, because the for loop is going to execute 3 times. So here it is P1, here let's say it is C4, C2, C5, C1, let's say C6, C3, let's say C7. So if you see, these are the processes that we have in the system. And the question is, how many child processes are there? So originally we have only one parent process. All these are the child processes, we can say, for the parent, right? So how many child processes are there? 7. 1, 2, 3, 4, 5, 6, 7. So 7 child processes are there. Or simply you can say that 2 raised to the power n minus 1 child processes will be there, where n is what? Number of times fork is called. Okay, so here how many times fork is called? N is equal to 3. So 2 raised to the power 3 minus 1, and that is nothing but 8 minus 1, 7. So 7 child processes will be created. Clear? What about this question? So here again 3 times for loop will be executed. You have 2 for statements. So 3 times 2 for statements. So we can say 6 times fork will be called. 6 times fork will be called. So simply using the formula 2 raised to power n minus 1, 2 raised to the power 6 minus 1, that is going to be 64 minus 1, 63 is going to be the answer. 63 child processes will be created. Clear? And here we have the previous year question, GATE CSE 2008. So here this for loop is executing n times, and we have one fork statement present inside the loop. The total number of child processes created, already I have explained you, it is going to be option B, that is 2 raised to the power n minus 1. Clear? These many child processes will be created. If they ask total number of processes, that is going to be 2 raised to the power n. Total number of processes. For child, 2 raised to the power n minus 1 is going to be the answer. Now let's see this last question. How many processes are created with these fork statements? This is very beautiful question. If you see carefully, it is little tricky also, but yes, now you have understood the concept clearly, you will be able to solve it. So let's see here. We have the header files here, int main. Now we are calling this fork system call. So let's say this is the first fork system call, this is the second fork system call, third fork system call, this is the fourth fork system call, and finally we have fifth fork system call. The question is, how many processes are created? With the first fork system call, how many processes will be created, or how many processes will be there? Basically 2 processes will be there. One is the parent process, another one will be the child, its child, right? When I call the second fork system call, again we have 2 processes, so 4 processes will be there. Total 4 processes will be there now, correct? Just see here. If I call for the first time, you are going to have P and C1. If I call for the second time, now you have how many processes in the system? 4 processes, correct? Now for the third time, you have 4 processes, so now we are going to have total 8 processes in the system, including the parent, right? Similarly, you can see this this approach as well. You can see 8 processes will be there, correct? Now carefully see this. If PID is equal to 0, then you have to execute this one. If PID is equal to 0. Now when we call, now carefully understand this, when we call fork for the first time, fork system call for the first time, child process, one child will be executed, so 0 value will be there for child and some non-zero value will be there for parent, right? That means every time when we call the fork system call, half of the process is going to be your child process, half of the fork system call is going to be your parent process. So when we have 8 processes, can I say out of these 4 are parent processes and half of it, that means 4 are child processes? So for this, PID is equal to 0. For these 4 processes, PID is not equal to 0. Clear? So if PID is equal to 0, then you have to call the fourth fork system call. So how many? Let's talk about the fourth fork system call. So only for these 4 processes, fork system call will be executed. So for 4, you are going to have another 8 processes. 8 processes, or you can understand through tree based approach also, but it's very simple. You can clearly say that after the third fork system call, you have 8 processes. Now out of that, 4 will be the parent process which are having PID not equal to 0, and 4 will be the child process where PID is equal to 0. Now if PID is equal to 0, this statement will be true for these 4 processes. So this fork system call will be executed for these 4 processes. Clear? Now you have another 8 processes. Another 8 processes in the system. So you have these 4 and now you have these 8. So total 8 plus 4 is 12. 12 processes are there in the system now. Clear? As of now, after this fourth fork system call is executed. 12 processes are there in the system. And finally, this fifth one will be executed by all the processes present in the system now. So you have total 12 processes. So total 12 into 2, that means 24 processes will be there. Total 24 processes will be there in the system, right? So 24 is going to be the answer. I hope it is clear to all of you. So that's it from this lecture, and you can join this WhatsApp MindMatrix channel, and you will be getting all the updates about our lectures and other more stuff. You can also join this Telegram doubt discussion group where we are going to post our PDFs, the session PDFs, and all the updates there. You can also ask your doubts there in the group. To join our doubt discussion group, you can also scan this QR code and you will be able to join easily. Clear? So that's it from this session. I hope you really enjoyed it. Like this session, like this lecture, and share it with your friends, those who are preparing for GATE 2024 and those who are preparing for GATE 2025 as well. And do subscribe to our channel so that you don't miss any notifications for the upcoming videos that we are going to provide you. Thank you everyone. See you in the next video. Stay tuned. Bye bye. Thank you.